Okay, okay. Did you already announce the room for the midterm exam?
We announced the time.
Time, but not the room yet, right?
Yeah,
We have 3 rooms, right? So we distribute this to them.
Yeah, but we will use 2.
2 only? One we cannot use.
We can, but we are
2
TAs
TA.
only,
Or I can ask one more of my student to join during. Yeah, 3 is better if we have, because we are so many students. So otherwise we cannot separate the student. Yeah. Okay, hi everyone. Welcome. So we are approaching the midterm exam. I hope it's correct. This will be next Thursday, right? Next week, Thursday. So this week, Thursday, and next week, Tuesday, there is no lecture. Yeah, so you have a lot of time to learn, okay? So please use that time. And as I said in the beginning of the semester, solve some exercises, but also try to explain those things we discussed to someone. Ask AI to question you, all kind of things, right? And all kind of things that help you to improve your confidence in applying the things that we discussed to other problems. Okay, so today we will do a little bit of lecture for the gases because I think we are still, I would like to include some things from the current lecture for the midterm, and then I will transition over to the preparation for the midterm exam. I have some summary slides which hopefully are helpful for you. So let's start with continuing the lecture a little bit. Now it's 12:20. So let's do like. Sorry, this is the summary. This one. Let's do maybe like 20 minutes lecture and then we go over to the midterm preparation. So last time we talked about gases and we learned about one equation which is called the ideal gas law, which summarizes all these relations we found from different people about these thermodynamic variables. So this is called the ideal gas law because it's valid only for gases which behave ideal, meaning that they don't interact with each other. Yeah, they don't realize that there are other molecules there. R is a constant. So this means that you have 4 variables, right? P, V, N, and T. So if you fix 3 of them, the 4th one will be automatically determined. This means you could now calculate. If you have 3 of them given, then the 4th one you can calculate with this. Or we can do some other calculations, as you will see now. A couple of examples. So this is an equation of state. It's called equation of state because it relates the thermodynamic variables of the system. So P, V, N, and T are called thermodynamic variables. So they describe the state of the system. And as you know, we can always categorize these into intensive and extensive, right? What do you think is so intensive and extensive? Is P intensive or extensive? Intensive, right? It doesn't change with the system size. How about volume? Right? N and T is intensive, right? So we have two intensive here, one here and here, right? So if we double the system size, this will double and this will double, right? It should be the same. So we could also say, let's divide both sides by n, then we get this equation. Now this one is called the molar volume. This is again intensive. So now we have a relation of only intensive variables. This is another way that we can write this one. And we learned also last lecture that the volume of a given amount of particles is always the same for an ideal gas, right? At a given pressure and temperature. This is what we can immediately see. So if we fix P and T, then V over N will be determined. This is around 22.4 liter per mole at 1 bar and room temperature. Yeah. Okay. What else? Okay, let's do some example here. We have a sample of ammonia gas with a volume of 7 milliliter and a pressure of 1.68 atmosphere. The gas is compressed to a volume of 2.7 at constant temperature. Use the ideal gas to calculate the final pressure. Okay, so we just write up first what we know. We know the initial volume. Let's name this V0. It's 7 milliliter. We know the initial pressure, 1.68 atmosphere. The gas is compressed to a volume of 2.7, so the final volume is, volume. Final volume is 2.7 milliliter. Okay, so we are given 3 variables. So what we do is we write down the ideal gas for initial and final state. In both cases it should be valid. So P0, V0 equals N0 R T0. And then P1, V1 equals N1 R T1. Okay, and now we know that N0 and N1 are exactly the same. So we can just write it as N. And also the T will be exactly the same. And now you can see the right sides are exactly the same. So you can just write P0, V0 equals P1, V1. And this you can solve this for P1. This gives you P0, V0 over V1. Right? And now you just, you can insert everything and you can get the answer. Yeah. So the key is always identifying what remains constant and what is changing. And in this case, this will give you the final equation. So this is here the calculation. P2 equals V1 over V2 P1. Insert everything and you get 4.4 atmosphere. And the volume decreased, so the pressure should increase, right, to keep nRT constant. Okay, this is another example. I think I will skip this one because it's doing the same principle. Only this works with temperature, so when you work with temperature, always make sure to convert to Kelvin, right, because Kelvin is the SI unit. So just convert to Kelvin, and then in this case it's the same thing. You have in this case the temperature 1, temperature 2, and volume 1 given. The pressure and N are constant, so you can rewrite this thing. Rewrite the ideal gas law so that all the constant things are on one side. Okay, so P P0 over NR, sorry, P over NR equals T0 over V0, and then this also equals T1 over V1, right? So that will be the relation you can identify here. You just solve this for V2. In this case also the pressure was changing. So in this case you would actually need to include the pressure here also in this term. So you have V0, V1 here. Okay. And then you solve this one. Yeah, NR is constant, so PV over T is NR. And then you just equalize those two. P1 V1 over T1 equals P2 V2 over T2, or I did it inverse way, it's the same thing. And you solve this for V2. Okay. So idea is always you put the constant things on one side of the equation and all the things which are not constant on the other side, and then you equal those, and then you have your equation that you need to solve. Okay. Okay, so I think I skipped this one. This is exactly the same thing again. You can look at this example by yourself. Okay, so let's do like some join-ins here. Which of the following graphs represents a plot of P versus V for an ideal gas at constant T and N? Who thinks it's A, B, C, D, E? Okay, so P and V, right? P and V. P equals nRT over V, so it's proportional to 1 over V, right? So it should be E, right? It's a hyperbolic function. 4 identical 1 liter flasks contain the gases helium, chlorine, methane, and ammonia. Each gas is at 0 degrees Celsius and 1 atmosphere pressure. Which gas sample has the greatest number of molecules? Okay, 1 liter flask, same temperature, same pressure. Who thinks it's A, B, C, D, E? Yeah, should be the same. The same volume, same temperature, same pressure. If you fix the pressure, volume, and temperature, then N is given, right? So for an ideal gas, they will all have the same particles. If they are not ideal, then the story is different, right? But as long as they are ideal, they will be the same. Okay, so let me skip these ones. I think this is pretty clear. Okay, so this is about this molar volume which I talked about before. So we can calculate nRT over P, which is the volume, and we insert 1 mole, or we could divide N over N, and we get 22.42 liter per mole. That's the molar volume, the volume that 1 mole of gas takes. Okay, it's actually 0 degrees, sorry, I wrote room temperature at 0 degrees and 1 atmosphere. That's actually the condition for this. And we call this usually standard temperature and pressure, STP. Okay. Okay. One more example here. Calcium oxide is produced by the thermal decomposition of calcium carbonate. Calculate the volume of CO2 at STP produced from the decomposition of 152 gram of calcium carbonate by the reaction. Okay, so we are given the mass here. We want to calculate the volume of CO2. Okay, where are we going? We want to use stoichiometry to determine the volume of CO2. We need to balance the equation. In this case, it's already balanced. We know that 1 mole of gas always takes 22.42 liter for an ideal gas. So what we need to do is we need to just calculate the mole of calcium carbonate by our favorite equation, n equals m over m. With the molar mass of calcium carbonate inserted, we get 1.52 mole. And then we can see that the mole of CO2 should be same as the mole of calcium carbonate. So we just need to multiply this by the molar volume. Right? So take the molar volume here, multiply this by n, and then we get the volume. So this is 22.4 liter per mole times 1.52 mole, and this gives us 34.1 liter. Okay. This one Vm is, I just defined this as a molar volume, V over N. They don't do this in this lecture, but I like to work with variables and equations, so I prefer to define it properly like this, and then everything should work out. Okay. I think this example is pretty similar. Again, we need to balance the equation, use ideal gas law, so I'm going to skip this one here. Feel free to go over this and let me know if you have any questions. Okay. Okay, so instead of formulating the ideal gas equation with the molar volume, we can also, if we want, introduce the mass and the molar mass, right? Because you know that the mole number, we can always write it as the mass over the molar mass. So if we do this, we get another equation, which is P equals mRT over V and the molar mass. Let me write this down here. And we can realize that mass over the volume, this is just the density. So we have density RT over molar mass. And you can see now again we have only intensive properties, right? So we can always formulate the equation of state using only intensive properties. So that is really a characteristic equation of our system, right? The extensivity of the equation always can be cancelled out so that you get a pure intensive equation. So this was the one equation, and the other way I said before was RT over the molar volume. So these are two ways to write the same equation using only intensive properties. Okay. So this is just another example. The density of the gas was measured at a certain condition of pressure and temperature, 1.95 gram per liter. Calculate the molar mass of the gas. Okay, so you're given pressure and temperature and the density, just insert it into that equation, right? And then you have it. Density, pressure, temperature, everything inserted with the SI units. So I will give you this constant in the exam. You don't need to memorize it. Yeah, I will give you such constants. You just need to make sure that you are able to convert the units, right? Let's say I give you this constant in bar and also Pascal units. Bar we didn't do in the lecture. In Pascal units, then you need to insert the pressure in Pascal. It cancels out, right? If I give it in atmosphere, you should insert the pressure in atmosphere. So everything should cancel out with the units, right? So be careful about that one. Okay, this is the molar, so this was the molar mass in this case that we solved for. What happens to the density of a gas contained in a rigid steel container as you heat up the gas? A, the density of the gas increases. B, the density of the gas decreases. C, the density of the gas doesn't change. Okay. So who thinks that A, density of the gas increases, decreases, doesn't change? Yeah, so we have a gas in a rigid container, so the volume is fixed, right? The volume is fixed. Yeah. The volume is fixed, but the density is just defined as mass over the volume, right? And we are not changing the mass, so there cannot be any change in the density. But what happens if we have a movable piston as we heat up the gas? Who thinks that the density of the gas increases, decreases, and doesn't change? Yeah, it should decrease, right? The volume increases. At the same time, that means that the density will decrease. Okay. Skip this one. Which of the following is a reasonable estimate of Okay, so this is just another time solving the ideal gas equation. I think we don't need to do like thousands of examples for the same thing. So that's why I'm skipping this. Yeah, this is also just the usage of the same equation again. Okay. Let me just quickly see how far I want to go today. Dalton's law. Yeah, I think we're not gonna make this to Dalton's law because this will be a new topic. We should have enough time to do some exercise for this. So maybe let me do some cut at this point. So we do everything until here, before Dalton's law, slide 116. Okay, so this will not be included anymore in the exam. Okay, everyone has it written down. From that, after that, we will move it to the final exam. Okay, then let's move over to the exam preparation. So a couple of things to keep in mind for that. So this time we will have three rooms for the exam because we are many students and I don't want you to feel that you need to look what your partner is doing. So didn't I put this already in the Dropbox? No? Sorry. Oh, sorry. I think it should be in the Dropbox folder. You don't need to make any picture for this one. Let me see. Yeah, it's already there. It's in the Dropbox folder. So we have 3 rooms. The TAs will, you don't need to take pictures, guys. 사진 안 찍어도 돼요. 잘 생기는지 알았는데. So we have a video and we have the slides in the Dropbox. Yeah, these things. This is what you should take a picture. But you never take a picture of this. I don't understand why, honestly. But what I write on the board is really important. That's the most important thing. I will ask you questions about the things I write on the board, right? What I write on the board is what I consider important, not what is on the slides. So those are even more important. But anyways, just for next time. Yeah, 3 rooms, distribute all the students. Time is wrong. Not 1:20, please don't come at 1:20, then everything is over. And then if I don't change it now, then you will blame me. And in the end, you said, no, professor said it's 1:20. 1 second, let me change this here. So our lecture time is 11, so you should be there 11:50. And also not PM, not in the night. AM, okay. So let me save this now. It's on the video, so
Is it Thursday?
yes, Thursday. Yeah, sorry. I didn't change the slides from the last year. I just put them here. Okay. Let me save this one for everyone. Okay, so next Thursday, 11:50, please be in your room. Does anyone have a problem to come at 11:50 or like anyone, if anyone is late, so when can you come? 12? Do you have another class before or exam before? Maybe you can leave the class a bit earlier.
That is in the main campus, so it is a little far.
Okay, but anyway, still you should, if it's just normal class, if you can, please try to go a bit earlier, but if you are there at least 5 minutes before, it's fine. But for the others, please be there like 10 minutes before. Otherwise, we cannot start at 12 then. And we have only the lecture time, so then you have less time to do it. So, and since all the 3 rooms should be equal, right? We don't want like one room to start 10 minutes late because of one person. So please be there at this time. Yeah. Okay. What else? You should bring a calculator and a ball pen, blue or black. No red pen. No pencil. Okay. We will provide the paper to you. You don't need any paper. And you should bring your student ID. Yeah? So these are the most important things. So during the exam, you don't need anything on the desk. Only your ball pen, water, calculator, and student ID. Those 4 things. Okay? But we will do this. We will check this during the exam, so don't worry about it. All the physical constants I will provide to you. Don't memorize them. And I will also provide you with the periodic table. Yeah? Only thing you need to memorize is these equations we had, right? N equals m over m. What is the molar volume? What is the density? Ideal gas law. These are the equations that you need to know, and you need to know how to use them, right? Okay? And of course, units, you need to be able to convert within the units we had in the lecture. There will be also some quick knowledge question, like multiple choice, similar to the short tests. And also there will be some calculation questions, which are a bit longer than what we had in the short test, right? Because you have more time to solve the problems. So yeah, my recommendation is focus on what is on the summary slides as the main topics, and then go back to do exercises with the lecture slides for the different things. Zomda book has also additional exercises, so feel free to do them and practice more. So we started the semester with talking about the foundations of chemistry. So I don't want you to learn about all the history of those things. That's not that important. For me, important is that you know how to deal with significant figures, right? So we will subtract points in the exam if you don't use significant figures correctly. There will not be like a specific task, like round this number to significant figures, right? That's something you need to always do whenever you calculate something. So we will always subtract points if you cannot do it. Yeah. So please be sure to use them. We talked about the different like systematic versus random error, accuracy versus precision. Introduced some units to convert them into. No need to learn the US units, as I told you. Density we introduced, and we talked a little bit about the differences of solid, liquid, gases, and mixtures. And we had this chart of how matter is organized. That is also something which you should know how to read and use this one to categorize what you have. Then we talked about atoms, molecules, and ions. So maybe just roughly know the idea of that picture of atoms, like what was it that Dalton found, what was the picture that Thomson had in his head for an atom, what is the modern view of an atom, right? Where do the protons sit, the neutrons, how many protons, neutrons, and electrons we have for a given element, what are isotopes, what are ions, all those things we discussed, right? And then we had a little bit of nomenclature for naming some of the compounds, so just practice that again if you need to. Yeah, so we had these flow charts, so just look into that one more time and practice if you need. You already did that for the short test. So the good thing for you is that you already practiced a lot for the short tests, so you can just hopefully you have some knowledge to build on, and you can go maybe one step further and do some more exercises. Stoichiometry is obviously very important in the lecture so far, right? How to balance chemical equations, how to calculate relating the stoichiometric coefficients between different reactants and products, how to calculate the mass percentage, mole number, the number of particles, and mole number, molar mass. So all these things, and limiting reactant. So that was all the topics from the chapter 3. We also talked about combustion, a device, right? How we can use it to determine the empirical formula. We had some small exercise in the short test for that. We can maybe expand it in the exam, some questions like that. So it would be really good, I think, for exam. So some things like that, right? Then in the chapter 4, we talked about the different types of chemical reactions and solution stoichiometry. We talked about dissolution processes, water, chemical equations, and solubility. How do we define a solution? What is an electrolyte, right? You remember the differences between electrolyte, non-electrolyte. We talked about polar molecules and non-polar molecules, like dissolves like, right? All these concepts we talked about. Strong electrolytes, they dissociate fully into ions and they conduct a current, like salts, which are very soluble, but also strong acid bases, also strong electrolytes. And weak electrolytes have usually a smaller concentration of ions, because they don't dissociate fully. We introduced the concentration or molarity as the mole number per volume of the solvent. And maybe here I should clarify this a little bit more so that this doesn't lead to some kind of confusion. So this here It's the mole number of the solid over the volume of the solution. By the way, one thing I really want to also tell you here, because many of you will later maybe write their reports or their thesis in with some Word or LaTeX or others. So you need to write equations, right? When you write equations, all the words or abbreviations, they should be non-italic. All the symbols should be italic. Yeah, italic means, okay, if you don't know what italic is. Okay, very important, please keep that in mind. All my students, they cannot do this, and I'm getting really frustrated with this. This is a standard convention in science. When you write equations, that you put all the words in non-italic and all the symbols in italic. Okay, just side story from the exam preparation. And yeah, dilution, we talked about how we can calculate this, right, by equalizing the mole numbers. We talked about some simple rules for solubility. You know that alkali cations are really soluble, nitrate. At least those you should know. We talked about ionic, different equations, the formula, complete ionic and net ionic equations. Then we talked about what are acids and bases and how we can do titration. So let's say I give you an example in the exam and say, okay, I want to titrate this one with that, and I used up this amount of volume. What is the concentration of my titrant? You should be able to calculate it, right? Because the end point of the titration is when the mole number of protons and hydroxide ions is exactly the same, right? So you can use stoichiometry to calculate it. Oxidation reduction reactions, we also discussed. You have to be able to determine oxidation states and balance those redox reactions. And we can also do titration, so that's another thing you need to do. So I think one of the most important things is probably stoichiometry. Like, you need to be able to be very confident with stoichiometry of chemical reactions. That was, I think, the most focus so far of this lecture. And then we talked about gases. Let me quickly delete what we didn't do. So we did it until here. So all of this one. Is not included. I'll just save this again. Oh, wait a second. Okay, so then we talked about gases a little bit. So we talked about some proportionalities of these variables, and all of that led to this ideal gas equation. So be confident with using this equation in all kind of contexts, right? Always remember this is only valid if the particles don't come close to each other and they realize there's somebody else, right? How are STP defined, and what is the molar volume roughly, right? But you don't need to memorize this number in principle, because you can calculate it from this equation, right? So if you know what STP means, then you don't need to memorize 22.4 liter per mole. And the molar mass is also related for a gas with the density, temperature, and pressure. Okay, so these are the topics we dealt with so far. So do you have any questions for the exam? If you have any questions, please ask now, because the other students would be probably interested in that as well. So please ask me now about it. Yes?
Just to make sure the version on Dropbox for gases is much longer, should we just like not lower mass?
It's probably not updated yet. Let me see. It should be updated now maybe. Can you check again? I think now it should be. Or let me save one more time. Is it good? Okay. Any other questions? So usually in the last years I always handed out some kind of small papers so that you guys can ask questions if you have, because mostly you are too afraid to raise your hand to ask questions. But today I didn't have really time to prepare it. But yeah. Well, I think if you have any other questions, then you can also come to me after this class. So because I think we finish a bit early today, then you can come to me and we can answer some more questions here. Okay? Then wish you good preparation. Please prepare more than just one day. Yeah? You need to prepare. No, I mean seriously. I mean last year the students prepared less than one day for it. So okay, good luck and see you next week.
How many questions are we imagining for the exam? I did raise my hand.
It's a bit difficult to say. I mean, often what I like to do is some kind of questions which build up on another one. Like for the calculation question, I typically take something like calculate this, and then what is the next step now? Calculate this. But then I usually give the answers, so that even if you cannot solve the first one, you can solve the second one. So, but I like that usually because you can think about some kind of more bigger problem that you can answer, right? Sorry?
Is it plus one class period?
Yeah. So it's not that long, so we cannot do that many questions. So usually there will be like one or two multiple choice with like.
We like make the quizzes.
Yeah.
I don't like with the time pressure.
Yeah.
75 minutes?
Yeah, 75 minutes. Yeah. So because we cannot find a room for longer, which is then we usually have to do it in the evening or in the weekends, and I think that's not a good idea. In the evenings, nobody can concentrate anymore, so it's better we do it like shortly and like short and intense, short and painful, and then yeah.
Should I apply the significant figure in the middle of the calculation?
No, only at the end. Only when you report the end result. Yeah. So let's say we ask in this case for the pressure, then only write it for the final result. You can also shortly write a small sentence. The pressure is blah 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 or something. But just writing is also fine. Yeah. 11:45. And then you need to come here. Okay. So can you be here? When do you think you can be here? 11:55. 55분? Yeah. At least 55분. Yeah. Then it's okay, I think. Yeah, 12. If you come 12, it's a bit late because we need to start at 12. So, but if you can give your name to the TA also, then they know that you come a bit later. Then it will be fine. Yeah.
It's not related to
to midterm exam, but I wrote something. We have midterm exam, chemical midterm exam in 30.
Oh.
I think this is my mistake, but I just want to make sure there is nothing more than our lecture in 30.
30? No. So we have 30 and 28 we have normal lecture.
Yeah, no more lecture.
Yeah. So 23rd we have midterm exam, right? And 28, 20, 30, because midterm period is next week, right?
Yeah.
So 28, 30 we have normal lecture. Yeah.
Thank you.
Mm-hmm. Mm-hmm.
I'm wondering how many questions in the test and the test form, multiple choice or...
Yeah, multiple choice, some question multiple choice, and then some question for the calculation. So maybe, I don't really know like how many questions, it always like differs. Yeah, but typically, well, I have no idea actually how many. It's always hard to say because I always have to think about how much time it takes to solve the question. Like some question, there will be some easy calculation question also. I mean, usually I have like one easy calculation and one which is more difficult one, and then they have some subtasks, like maybe 2 or 3 subtasks. So I guess in total maybe like 5 calculation and then maybe 2 multiple choice or something, roughly, but it's hard to say. Yeah. Yeah.
I want to know how much percentage of short test when
For the grade?
yeah.
I think I announced in the beginning of the year. So this is, I think, 30. Oh, just 1 second. This is. Wait. I actually did something. 1 second. Because of the cable, it was not opening. Okay. 23rd, right? Short test is 30%, and then midterm 35 and final 35. Yeah. Yeah.
I was wondering, so Boyle's law, its measured pressure is in millimeters mercury, right? But for ideal gas law, it's in ATM, and I was
It
wondering
depends on
why-
the unit of your constant, right? What unit do you give for the constant, right? I mean,
so it doesn't matter.
yeah.
Okay.
But in general, I would always use SI units, but you should match it with the unit of R, right? You can basically write the same law with atmosphere, then you just need R in units of atmosphere. Or if you use torr, then you need R in units of torr.
Okay.
So usually I will provide you that R in a certain unit, and you just need. I will provide you usually SI units. So yeah, you don't usually. I don't want you to like use other units. So I will probably, very likely, I will give you SI units. But you must still be able to convert the pressure between torr, atmosphere, and Pascal. Yeah. Yeah.
So that's what you meant when you said that we should be looking out for.
That's right.
Okay, I
Just
see.
look out for the unit of the constant.
Okay.
Yeah.
Thank you
But
so much.
yeah, sure. Yeah. Good luck.